Greetings, students, and welcome back to class. Today we are going to be explaining the concept of inverse variation. What is inverse variation and how this can be used in real life situation. So by definition, if two quantities are related such that an increase in one leads to a decrease in the other and vice versa, then the two quantities are said to be inversely related. So vice versa means the other way around. That is, a decrease in one leads to an increase in the other, then that relationship is said to be an inverse relationship. So an example where two quantities are related and an increase in one leads to a decrease in the other would be the number of workers required to do a particular job and the time taken to do that job. So if we have 5 people doing the work, they will take a particular time. But if, for example, 10 person goes to do that same work, they will take less than the time the 5 person took. That means that if the number of workers increases, the time taken to do that work will decrease. And if the number of workers decreases, the time taken to do that work will increase. Another example is the relationship between the velocity of a body and the time that body takes to cover a particular distance. So if the velocity increases, the time taken to cover the distance will decrease. Take for example, you are leaving from point A to point B. If you increase your velocity between those 2 points, you take less time to reach to point B. But if your velocity decrease, what happens? You take more time to reach to point B. So these are 2 examples, and there are many other examples we'll consider. But we are going to look at the mathematical definition of inverse variation and try to solve a problem. So let's begin. Let's say there is an inverse relationship between two quantities x and y. If we say x varies inversely as y, then this can be stated mathematically as x is equals to k over y. That is the mathematical representation of the statement x varies inversely as y. Now, this k is called the constant of proportionality. For every relationship that exists between two quantities, there is a constant of proportionality. There is a constant that relates these two quantities. So take for example, you want to find the relationship between the United States dollars and that of the Liberian dollars. You already have one United States dollars is equal to 150 Liberian dollars. So that is the relationship that connects the Liberian dollars to the United States dollars. And we can find a given Liberian dollar for a particular United States dollars. Say for example, we want to find what would be the equivalent of 2 United States dollars. That would be 2 times 150, which will give us 300 Liberian dollars. So for that, the relationship between the United States dollars and that of the Liberian dollars is a direct relationship, which we explained in our first video. So if you haven't seen it, we ask you to check that out. Great. So x is equal to k over y is the mathematical explanation or the mathematical representation of the statement x varies inversely as y. So let's look at an example, and then we will explain to you how this can be used to solve a particular problem. If x varies inversely as y and x is equal to 1 when y is equal to 8, find y when x is equal to 4. Now, based on the question you are given, you are going to select the variable to use. So in this question, you are told that x varies inversely as y. So you are going to write the mathematical explanation or the mathematical representation of that. That is an equation. So since x varies inversely as y, we say x is equals to k over y. So if we have a varies inversely as b, you have a is equal to k over b. If m varies inversely as t, m is equal to k over t, and so on. Now we're told that x is equal to 1 when y is equal to 8. So represent this x with 1. So 1 is equal to k over, and y at x equal 1, y is equal to 8. Y is equal to 8. And then you solve for k by cross multiplying. So k will be equal to 8 times 1, that's 8. So the constant that relates x and y is 8. K is equal to 8. Therefore, And the equation that connects x and y will be x is equals to 8 over y. This will be the equation that connects x and y. Just replace the value of k. Now we go back and then it tells us that find y when x is equal to 4. Find y. So 4 is equals to 8 over y. We want to solve for y. So we cross multiply. We have 4y is equal to 8. And if 4y is equal to 8, we divide this by 4 and divide this by 4. We have y is equals to 2. So if x equal 1 and y equal 8, we are told to find y when x equal 4. So let's see why make this an inverse variation. X is 1 when y is 8. Now x increases to 4. From 1 it goes to 4. Y leaves from 8, it goes to what? 2. So an increase in x causes a decrease in y. And that is the general idea of inverse variation. So I'm going to give you an example to try, and after you solve it, post your answer in the comment section along with the solution, and we will respond to you. So let's get the example problem. For practice, you are going to do this example, and we encourage you to post your solution in the comment section for feedback. But as a hint, we are going to give you the relationship between the two quantities in this question. So the electrical resistance R of a wire varies inversely as a square of its radius. If the resistance is 0.8 ohms, remember resistance is measured in ohms, when the radius is 0.4 cm, find the resistance when the radius is 0.7 cm. So as a hint, we are going to give you the relationship, and we expect you to use that relationship to solve this problem. So let's get a relationship. The electrical resistance R varies inversely as the square of its radius. So that's K over R squared. So R is equals to K over R squared. Capital R is used for the resistance, and small r is used for the radius. So thank you very much for watching today's video, and we hope to see you in future videos. Bye.